Hi guys, this is Ariel Bronstein, and I'm going to walk you through how to do the CALC BC free response 2012 number 4. So the question starts by giving you this table of x values and their corresponding f prime values. So the question says, the function f is twice differentiable for x is greater than 0 with f of 1 equal to 15 and f double prime of 1 equal to 20. Values of f prime, the derivative of f, are given for selected values of x in the table above. Part A then says, write an equation for the line tangent to the graph of f at x equals 1. Use this line to approximate f of 1.4. So when you're finding a tangent line, you need two pieces of information. You need a point and a slope. So the original question gives you both of them actually. So they give you your point, which is 115, because they give you that f of 1 equals 15. They also, by looking at the table, you can see that f prime of 1 equals 8. So that's your slope at the point. So then you can put both of those values into point-slope form, and you get y minus 15 equals 8, the quantity of x minus 1. So then your next step would be to do the approximation of f of 1.4. So what you would do is then plug in the value 1.4 for x. So you get that y equals 18.2. Part B says, use a midpoint Riemann sum with two subintervals of equal length and values from the table to approximate the integral of 1 to 1.4 of f prime of x dx. Use the approximation for the integral of 1 to 1.4 of f prime x dx to estimate the value of f of 1.4 and show the computation that leads to your answer. So the first step to this would be to find the Riemann sum value. So one thing to make sure you watch out for is that you see they're asking for the midpoint Riemann sum, not the left or right. They want two subintervals. So your first interval is going to be from 1 to 1.2, and the other would be 1.2 to 1.4. So each would be a step of 0.2, which is here. So these are the base lengths of the rectangles. Then because you're using the midpoint, you want to find a value in the middle between the values of 1 and 1.2. So in this case, you would use 1.1. And so that value is 10. And then the value at 1.3 is 13. So you plug both of these in, you do some multiplication, and you find that it equals 4.6. In order to find the approximation of f of 1.4, you have to go back to the fundamental theorem of calculus. So you know that the integral of 1 to 1.4 f prime of x dx equals f of 1.4 minus f of 1. So then you can do some simple algebraic rearranging to find out that f of 1.4 equals f of 1 plus the integral. And then it's just simple plugging in values. So you know that f of 1 equals 15, and the integral value is 4.6, which we found up here. So then you simply add them together, and you get that the approximation is 19.6. Part C then asks you to use Euler's method, starting at x equals 1, with two steps of equal size to approximate f of 1.4. Show the computations that lead to your answer. So Euler's is just another approximation method. So the first thing you need is the first line at x equals 1, which is, the tangent line is y minus 15 equals 8 times the quantity of x minus 1, which we got from part A. So then, to find your next step, you would plug in your next x value, which is 1.2, and you get that then your y value is 16.6. To find that tangent line, you would need your second slope, which is 12, which you get from the table they give you. So then you write this tangent line, and you get that y minus 16.6 equals 12 times the quantity of x minus 1.2. So your final step would be to plug in 1.4, and you get that f of 1.4 equals 19. So then part D asks you for one more approximation. They say, write the second degree Taylor polynomial for f about x equals 1. Use the Taylor polynomial to approximate f of 1.4. So, the general form of a Taylor polynomial is the nth derivative of f evaluated at a times x minus a to the n over n factorial. So the first term is going to be the 0th term. So that means you plug in 0 for anywhere you see n, and then anywhere you see a, you would plug in 1, which is because you're approximating it about a, or about 1. So you would get 15 times x minus 1 to the 0th power over 0 factorial. You then repeat this for 1 and 2. Because they want your second degree Taylor polynomial, so you would need the highest power is 2. That then gets simplified to this right here. And to do your final step, which is then approximating, anywhere you see x, you plug in 1.4. And you get 19.8. So that would be the end of the problem. So sort of let's go over what makes this problem very difficult. First of all, there's a lot of simple algebra, which should be simple, but this is a non-calculator problem, so it's really easy to make little mistakes in all the simple algebra, which can throw off all your answers. Next issue is they ask you for all the different kinds of approximations, and there's lots of little details with each one, and they're quite easy to just mix up. Some of those details is they don't ask you for a 4-step approximations for Euler's or Riemann sum, even though they give you 5 different values in the table. So you just have to watch to make sure you don't mix them up accidentally. And then if you don't know what to do, my recommendation is get any points you can. So if you know how to find the tangent line, as they ask in part A, you find that and you get those points there. If you don't know how to do a Taylor, skip that part, but you'll still get the points for part A. And finally, if you need more help, all of these are the CALC BC problems that go over similar concepts as this problem. Thank you.